Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the square root function. So the square root is a function. That means for each input, you only get one output. See, x squared equals 4 has two solutions, 2 and negative 2. But if you square root 4, it only has one solution. The square root of a number is always non-negative. It's either 0 or positive. So square root of 4 is 2. It's not negative 2. And that's very important for how we're going to graph it. We're going to look at the graph of y equals root x. So because it is a function, one input, one output, it will satisfy the vertical line test. So before we go into graphing that, we should take a look at the domain and range. This helps us understand where our graph is going to be placed. So if you've forgotten, the domain means the set of input values you can have. When we're graphing, that's the set of values x can take. So when you're square rooting a number, remember you cannot square root a negative. Square root of negative 1, for example, doesn't exist. So x has to be greater than or equal to 0. And this is how we write it properly. The set of x values such that x is greater than or equal to 0. You can square root any number greater than or equal to 0. So what about the range? Well, I just told you before that when you square root a number, the answer you get is never negative. So it turns out y also has to be 0 or positive. So that means our graph is just going to live in this quadrant here where x and y are both not negative. So if we don't know what it's going to look like, we can always substitute a few points. If x equals 0, y equals square root of 0, which is 0. If x equals 1, y equals square root of 1, which is 1. If x equals 4, y equals the square root of 2, which is 2, and so on. Square root graphs look like this. Now this point here is shaded in because that point is included. So I put the arrow here because it goes forever in this direction. I don't put an arrow here because it certainly doesn't go forever in the other direction. It starts here and goes on forever. So square root graphs have this shape. They're not linear, they're just curves that sort of taper off. The gradient is low. You have to have a big change in x to get a change in y. So that's what the graph of y equals root x looks like. So now let's look at the graph of y equals negative 1 minus the square root of x plus 1. So this looks a bit difficult, but I think we're going to be helped by calculating the domain and range. So the domain is the set of values that x can take. Well, square rooting causes a problem when you square root a negative number. We can only square root something that is 0 or greater. So that means x plus 1, the thing I'm square rooting, has to be greater than or equal to 0. So that means x has to be greater than or equal to negative 1. And of course, writing it properly, the set of all x values such that x is greater than or equal to negative 1. All right, let's now look at the range. So for the range, remember this can never be negative. It either has to be 0 or positive. So if you take negative 1 and you subtract a non-negative, you're making it smaller. So y will always have to be smaller than or equal to negative 1. Okay, so that really helps us know where the graph is going to be located. Y has to be less than or equal to negative 1, so the graph has to always be below or at this line. And of course, x has to be greater than or equal to negative 1, so it's going to start here. So let's substitute in a few points. So if x is negative 1, so that is the lowest value x can take, we get minus 1 subtract square root of 0, which is minus 1. So minus 1, negative 1 is this point here. That's where this graph starts. If x is equal to 0, we get minus 1 subtract square root of 1, which is negative 2. If x was equal to 3, we get minus 1 subtract square root of 4, which is negative 3. So 3, negative 3, is down here. And now we just use what we know about the shape of square root functions. So it sort of like tapers off in that direction. It starts here, it goes forever in only one direction. And it's actually a curve. It might look a bit linear depending on your scale because it takes a long time to increase, which of course means it can look like the graph is going almost perfectly horizontal at times. All right, let's now look at solving an equation involving the square root function. Let's solve this equation here. 4 minus square root of 3 minus x equals 1. So we need to undo what's been done to x. So x was first times by -1, 3 was added, then square rooted, then the minus there, and the 4 was added last. And it was added because it's positive. So because it was added last, the first thing I undo, I'm going to subtract 4 from both sides because plus 4 minus 4 cancel each other out. So I'm left with -3 square root of 3 minus x. 1 minus 4 is -3. So you can change the sign of one side of the equation as long as you do the same to the other side of the equation. Now I'm going to square both sides. And if you square a square root, you just get rid of the square root. 3 squared is 9. X is, of course, -6, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.